principle of moments, also known as Varignon's theorem, states that the moment m of the resultant r of a system of forces with respect to any axis or point is equal to the vector sum of the moments of the individual forces of the system with respect to the same axis or point. This just means that the sum of the moments is equal to your resultant, or your moments. If you have a system, say force A and force B, that can be described with the resultant R, where R is equal to A plus B, then the moment created about point 0 by R, if you take the distance, or the perpendicular distance d, the moment about point 0 is equal to the resultant times that perpendicular distance d. That is also the same thing as taking the perpendicular distance for each of the components. So if I extend A out and take the perpendicular distance here, I have a perpendicular distance to the vector A and a perpendicular distance from 0 to the vector B. So it's just summative. So basically, in a system then, we have the sum of the forces and the sum of the moments So let's take a look at an example. If I have a force being applied of 500 pounds upon point 0, it's 3 feet in this direction and 5 feet in this direction. What is the moment about 0? This angle is 30 degrees. So taking your typical moment is equal to the force times the perpendicular distance, I would have extend this, and I can get the perpendicular distance here. But then we have some pretty complex geometry that we have to figure out to get d. I get that d is equal to 5 cosine 30 minus 3 sine 30. So then if I want to sum my moments, or get my moments, not sum them, if I want to get my moment about 0, I take 500 times the perpendicular distance, 5 cosine 30 minus 3 sine 30, to get 1415 foot-pounds. And if I put my finger on 0 and push in that direction, it's going to go counterclockwise. So that's using that method. But a simpler method would be using the principle of moments, where I break them up. So I can treat this force as having an F, or an X component and a Y component. So my Fx is equal to 500 cosine of 30, and my Fy is equal to 500 sine of 30. So then if I want to get my moments, my moment, with this being my positive direction, about 0, is equal to Fx times my perpendicular distance plus Fy times my perpendicular distance in the y direction. So, looking at this, I have my Fx, F500 cosine 30, times my perpendicular distance to get to that, which would be 5 feet. And then I have my Fy, which is 500 sine of 30, times the perpendicular distance to get to the y component here, which is 3 feet. But now I have to pay attention to the direction. So if I take my finger and I apply the force Fx, it's going to spin in the counterclockwise direction, which is going to be negative. And then if I hold this and I apply in the Fy, it's going to be in the clockwise direction, or counterclockwise direction, which is positive. So I end up with 1415 foot-pounds, and it's going to be negative, which indicates that it's in the clockwise direction.